Let's see, space. Now the rigid body motion here, AC equal to 0, 1, 0, 0, and BC here equal to 1, 1 over 1. So that's for rigid body motions. By the way, I add C here, just this is a continuous rigid body. This body is M, W double dot equal to U. Right? So with rigid body defined as M, W dot equal to U, and the C here means continuous. Last hour I forgot to put a C here. This means continuous time. This C means continuous time. Alright. With rigid body motion we can write this is state equations and measurement equations, and AC equal to the 0, 1, 0, 0, BC equal to 1, 0, and X really equal to W and V. Where V is equal to W dot. Then let's look at this. For the displacement, this is just a summary, okay? Displacement measurement, then C equal to 1, 0, and D equal to 0. For velocity measurement, C equal to 0, 1, D equal to 0, right? Because Y equal to W, so that equal to 1, 0, WV plus 0 U, right? Right? Agree? And that implies Y equal to W dot equal to V equal to 0, 1 WV and plus 0 times U. Agree? And for Excel measurement, then C equal to 0, 0, and D equal to 1 over M. That implies Y equal to W double dot equal to V dot, then equal to the M inverse U. Into 0, 0, WV plus M inverse U. Right? Okay. That's a summary for rigid body motions. It's also important to know the eigenvalue of rigid body motions are 0, 0. Eigenvalue of this is 0, 0. Okay, that's a rigid body motion. And that gives you the state. This is the state space model. This is the state space model. and to be more accurate, call continuous time. State space body. That means which body state continuous time state space body. Okay. So for the acceleration measurement in the state space model for a rigid body motion, the matter of fact the c is 0, 0 and d is 1 over m. For velocity measurement, c is 0, 1, d will be 0. For displacement measurement, c will be 1, 0 and d is 0. Okay, now the d here, so we know that AC we call state matrix, BC is input matrix, C is output matrix, and D we call the direct transmission matrix. That's defined there. Direct transmission matrix. Okay, that's direct transmission matrix we call D. So D is direct transmission matrix. So all the AC, BC, CD have names. So this is continuous time. A means state matrix, B is input matrix, and C output matrix, D is direct transmission matrix. Okay? That's a summary for rigid body motions. Let us go on for vibration motions like this. And I'll show you what it is all the time. And you write in terms of matrix equations. And then we can also write the this way. Okay, now if you already copy this, I assume already copy this. I'm going to erase it. And then I'm going to do this and leave this, okay, and I leave that, and then I'm going to rewrite this, okay, now, and this is different, now this is vibrational motions, alright, I'm going to summarize this, vibrational motions. Vibrational motions dot m w double dot plus k w equal to u. Alright. For this, AC, the state matrix AC equal to 0, 1 m inverse k 0. BC equal to 0 m inverse. That's my BC. So that's my state matrix. This is my input matrix. That's 0 m inverse. For displacement, displacement y equal to w. Now equal to 1, 0 WV, right, plus 0 times U, so that means my C equal to 1, 0 by D equal to 0. That's my displacement. Agree? Okay, so my displacement of vibration matrix equal to 0, 1 WV plus 0 dot U. That means my C equal to 0, 1 and my D equal to 0. Agree? Can you see it? Alright, we have, that's a displacement That's velocities, my Excel. Now y equal w double dot equal to, now it's different now, will be m inverse minus w plus m inverse u. That means my c equal to, what is my c now? My c equal to m 0. My d equal to 1 over m. Am I right? Yeah. Okay. So my rigid body motions are my vibrational motions. The AC different, BC the same. In the displacement measurement, C the same, D the same. In the velocity measurement, C the same, D the same, but in acceleration measurement, C has value. That's minus k over m 0. Right? Agree? Any questions? D has value. But in rigid body motion, C has no values. Do you see any important things here? If you look at displacement measurement, velocity measurement, they always got no V. The only measurement that has the D values is the XL measurement. This is because you have that U terms. So in the XL measurement, you have the C